This video presents a new game from the UFrameIT project, which uses MMT for the underlying logic and Unity for the visualization. The goal of the game is to teach the player about quadratic movement functions. The player's task is to get a package on the other side of the river with the help of a slingshot. The slingshot is fixed in place and positioned at an angle of alpha equals 45 degrees. The only thing the player can change in the slingshot is the speed at which it releases the package. Setting it to the maximum speed will result with the package ending up in the river, however. If the speed is set correctly, the package will hit the green area within the river and safely bounce to the other side. For the calculation of the correct speed, a scroll can be used. This scroll uses the information about the slingshot, the gravitation, and a point on the green area within the river. The slingshot and gravitation are already provided to the scroll beforehand, but the extra point is missing. So the player first creates a line from the back of the slingshot to its front, which extends to the other side of the river. On said line, the player selects the extra point on the green area within the river. This process ensures that the slingshot is correctly aligned with the point. The scroll on the side of MMT calculates the correct velocity and provides it back to the player. The input of the scroll consists of the release point of the slingshot, the point in between the river that is to be hit, and the gravitational force. With that information, MMT first calculates the height and distance between the slingshot and the point in between the river. For the next step, a quadratic formula determining the y position and a linear formula determining the x position are created. Since the slingshot is propped at an angle of 45 degrees, the velocity in both x and y directions are the same. Both formulas are combined and solved for the time of flight of the package. For the final step, MMT returns the calculated velocity as the output of the scroll. The calculated velocity, the release point of the slingshot, the gravitation, and the aerial information are provided to another scroll. With this scroll, MMT calculates the entire movement path of the package from start to finish and returns it as a list of movement functions and a list of corresponding timeframes. To visualize the calculated movement, Unity goes with a fixed frame rate from the time 0 to the final time of the package's movement. In each frame, the current time is input in its corresponding movement function, which in return yields the current position of the package. In summary, the game does not use the Unity physics engine, but instead does the calculations symbolically in the MMT knowledge processing engine. Thus, the calculation and reasoning process is made explicitly transparent and can be used for explanation and learning.